friends. Welcome back to another wonderful virtual MOSI. My name is Ian Reed, and today we're going to do something really cool. We're going to create the permanent rainbow. Now, we've all seen rainbows, beautiful, colored. If you look even closely, you'll see that there are double rainbows there. But have you ever wondered what actually causes a rainbow? How does one form? All right, so I have a really quick demonstration. So we're going to pretend that my flashlight is the sun, and this is called a convex prism, okay? And so let's pretend, and it kind of does look like a raindrop, right? Cool. So let's pretend that it's raining these little prisms, all right? And then the sun's light is shining on it. If you look kind of closely, you can see kind of like a little patch of colors there. Kind of at the top, some in the middle, some at the bottom. And so what happens is that there are actually two things going on that's responsible for that patch of colors. One of them, something called refraction. Now, you've probably done this experiment before where you take a pencil, regular pencil, and you stick it into water. All right? Now, when you stick it into the water, notice that once it's in the water, it looks much larger than it out of the water. So what refraction is when light penetrates, goes through water, air, oil, or something that we would call a medium, okay? So once light penetrates that. Now, of course, this is the same size, but if you notice, it's kind of looking like it's at a different angle, okay? Skinny, but it looks magnetized. And so what your eyes do is your eyes say, that looks big. Brain says, it does kind of look big, but it's the same pencil. So sometimes they have a little argument. But you can see right here that the angle looks a little different and it's a little larger. Now, the great thing about science is, let's take something else into consideration. Let's try something else. So what if we had this wonderful glass staring rod and placed it into, or there you get the same thing. Notice skinny there looks like it's magnified there, all right? And so that's in water. But what if we do something different? So let's take a different substance like oil, okay? So we're gonna take oil and have another glass stirring rod. Now I want you to watch this. This is really cool. You can barely see it going through, and that's because the oil is a different substance than the water. So for materials like water, oil, and even steam lab air that we're breathing in, that's what we call a medium. And so you have something called the index of refraction. And so what that does is that helps us to know how well light can penetrate through these different things. And so that helps us. So refraction, so just remember that means light passing through, light going through. A lot of people think that sharks kind of have poor eyesight. Not really. Tell that to a school of fish. That is pretty wrong. All right? And so the other part would be reflection, just like when you see yourself in the mirror. All right? So you have refraction, you have light going through, and then what you're seeing is reflection. Some of it reflects back, and you're able to see the rainbow. Now, who developed this concept? Who came up with this? A guy by the name of Snell. Wilbur Snell. His father actually wanted him to be a lawyer. Can you believe that? But he didn't. He wanted to study math because he was really, really into astronomy. And so he actually followed in his father's footsteps. His father was a math professor at a college. And so he followed in his father's footsteps, and he comes up with this thing called Snell's law. Now, wait a minute. Mr. Ian, every time we see you, you always have these weird formulas. What's going on? Well, let me explain this so you can kind of see what's happening. So let's go back to our pencil. Okay? So we're going to take our pencil, we're going to put it back in the water. So you can see that the pencil is at an angle, right? And so that, remember, we put it through. Now, before the pencil went to the water, what is the pencil going through? Steam lab air, all right? And so going through that, now once the pencil goes into the water, it's no longer just in the air, it's now in the water. And so it's creating, again, that different sort of angle. And so what you are seeing back in your eye, remember your eyes giving this information to your brain saying that it looks bigger. And that is Snell's law, all right? It's all about the angles and how you're able to visualize things. And so thanks to refraction, light penetrating through, and reflection, light bouncing back, that's how we're able to see rainbows. So, are we ready? So let's look at what we need. So you need nice light, kind of intense light, clear nail polish, water, and, some black construction. Okay? Now, why do we need all these materials? Great question. Let me answer it for you. So, with the nail polish, remember we talked about that index of refraction? Well, nail polish is a thin film. All right? So for all you ladies out there who want you're able to get out of the house and go to the salon and get all coiffed up and poshed up and everything, nail polish is described as a thin film. So when you get a manicure or pedicure, what it does is it protects the nail because it's covering the nail and actually helps the nail to grow. So we need this because this is a thin film and this is going to help in us creating the rainbow. So we need the water as well because we need the light to penetrate the water, and we need something black so they can absorb it. So what we want to do first is take our piece of paper, place it into this container. Now notice it's kind of a clear container, but you can use aluminum foil container. If you don't have a clear container, you just need something that's going to help to reflect the light, okay? So just using this to have this, and then you want to pour water into your container. This is about 1 gallon of water. And you're going to pour in enough water so that you press it down, you have enough there so it stays in the bottom. And then you want to turn on your light. And you want to make sure, what helps you out is you want to make sure that the reflection, we talked about reflection, that you're seeing, that you're able to see that. I also have a pipette, or a squeezy thing, as I call it. All right? And so what we're going to do is we're going to draw some of the polish up into the pipette. And all we want to do is just squeeze drops in. And you can kind of see we have a lovely rainbow. And we want to leave it there for just a few seconds. I don't know if you can see there where my finger is, but you're seeing all these little fringy parts. That's what we're looking for. Smell that wonderful last time. All right? And so those parts let us know that it's almost time for us to pull out our black piece of paper. Okay? And so when you pull it out, you gotta be very careful. You wanna pull it out slowly. And I'm going to place it right here on this tray. You can see. So that you can the pattern that's there. And notice I have a paper towel so that it helps to dry it faster. The cool thing about this is we're going to do it one more time, and we're going to see if we can get the same kind of patterns. I'm going to get a, I can see. All right, and then going to sometimes the paper doesn't want to cooperate. Cooperate, paper. Thank you. And again, we just want to wait a few seconds. So we see our little friends back. Pull it up. And here you can see a little bit different pattern. All right. All right. So you see a little different pattern there that's starting to form. Now the reason I call it the permanent rainbow experiment is because I was in Publix one day and someone walked up to me and said, "Hey, I know you." And I said, "Okay, great. Remember that thing you made with us, the rainbow thing?" I said, "Yeah. You did it with us in our class like 5 years ago, and I still have it. So as long as you don't pick it once it dries, you will still be able to have that." And so that just gives you some information on how this experiment works. So like I said, you can try different things. You can use an aluminum pan, anything that's black piece of paper. Try a different type of nail polish just to see what you can get, and you can change it up for this experiment. And it is really great, and it is really cool. And so once you're able to understand and manipulate light, you can do all kinds of cool stuff. Many of the special effects that you see either in the movies or at the theme parks are because you have special effect technicians and engineers that are able to manipulate the way that you see light. So sometimes you see flashing light, strobe light, sometimes you see holograms and things of that nature. That's a way of manipulating the light so that you see things that you think are there and it doesn't really look like it's there, but that's because of the way that we're able to use light and the science of light. All right, so try this on your own. You can Google it, rainbow or polished rainbow, and you'll be able to do this, and you'll be able to get even more instructions on it. All right, do you have any questions? All right, no? Okay, well thank you. Please tune in tomorrow for Virtual MOSI. We'll be doing a cool field trip, sticking with our theme, which is the science of light and Light Week. Thank you very much for tuning in today, and remember, always keep discovering.